let's use f of x equals 2x plus 1. Okay. Now, if I were to graph this function, I know that plus 1 is what we call the y-intercept, right?
Yeah.
So what does that mean?
It means the value of y is 1.
X is 0, y is 1.
X is 0, y is 1, or I'm going to put a dot on the y-axis right here when y equals 1. Now the next thing I know is that my slope, 2x, the number in front of the x is the slope, which is the rise over the run, which is written as a fraction. It's 2, but I could think of that as 2 over 1, which means I'm going to go up 2 over 1. Remember that x-axis going to the right is positive and going to the left is negative. On the y-axis, going up is positive and going down is negative. So I'm going to count, I'm going to go up 1, 2 over 1. From that point, I'm going to go up 1, 2 over 1. I'm going to go up 1, 2 over 1. See how that makes a straight line?
Yeah.
Now what I'm going to do is I'm going to take my ruler and I'm going to draw my line through those points. I'm going to do it with a pen because my marker that I'm using, I want you guys to see it, but the marker's just a little too thick. So I'm going to do both. So there's my line. Okay? Yes? Well, just look at it. You have the y-intercept is 1, which means we're going to have a point crossing the y-axis as y equals 1. Or that occurs at 0, comma, positive 1. Then from there, we're going to go up 1, 2, and then over 1. Why? Because the slope is 2, which can be rewritten as 2 over 1. The positive 2 means we go up 2 units, 1, 2, and then the positive 1 means that we go over 1. So we're going to go up 1, 2, because it's positive, and then over 1 because it is positive as well. Does that make sense? Okay, so now what we're going to do is we're going to do another equation. This time we're going to do g of x is equal to negative 2x minus 1. Oh, actually, let's make that minus 2. Okay? So we're going to graph this one the same way. The negative 2 without the x is what we call the y-intercept, right? This is the y-intercept. So that means I'm going to come on the y-axis, go to the negative 2. In other words, this is going to cross the y-axis at 0, comma, negative 2, because that's what the y-intercept for this graph is. However, the number in front of the x, which is called the slope, which is sometimes referred to as the letter m, which is the rise over run, can be rewritten as a fraction, but now we're going to have a negative 2 over a positive 1. Right? Yeah. So now because the 2 is negative on the top number, what does that mean? That's right. I'm going to go down 1, 2 because I have a negative 2 here, and then I'm going to go over 1 because I have a positive 1. So because my slope is negative 2 over 1, I'm going to go down 2 over 1. So I'm going to start here. This is 1 point on the line. And then I'm going to come down 1, 2, and then go over 1. From that point, I'm going to go down 1, 2, and then over 1. down 2, and then over 1. Does that make sense? So I'm going to graph this with my ruler. I'm going to try to get this ruler to line up on the corners as nice as I can because it'll help me. And then maybe what I'll do is I'll highlight that so you can see the difference between the two graphs. So those are my two graphs. So now we're going to do a composite function, but I don't want to call it g of x. I would like to call it h of x. So we're going to say that h of x is equal to f of x plus g of x. Okay? So now the way that we're going to do this is we're going to make a table of values where I have my x values. We'll call these x values. Then I'm going to have my f of x values. Then I'm going to have my g of x values. And then I'm going to have my h of x values, which is the sum of those two values. So I'm going to make a table of values like this. And let's start with when x equals 0, when x equals 1, when x equals 2, when x equals 3, and see if there's a pattern, and then maybe we can form it. And then I'll show you how the values and the patterns all come together. Where? No, it's g of x. No, it's a g. All right, so now from here, when x equals 0, remember that f of x, and I'm going to calculate a few of these, and then we'll look at the graph and see. So remember that f of x, when x equals 0, I'm saying f of 0 is equal to 2 times 0 plus 1. What's 2 times 0? Okay, and 0 plus 1 is 1. So when x equals 0, my f of x should equal 1, right? Yeah. Now if I come over here, that's exactly what we have, 0, comma 1, if I look at the graph. Now let's do that for x equals 1. So now if I say f of 1, I'm going to say 2 times the quantity 1 plus 1. What's 2 times 1?
2.
Plus 1 is? 3. So now if I come and I look at my graph, when x equals 1, my y value does in fact equal 3. Correct? Because we went over 1 and then up 1, 2, 3.
That's the part I don't because like you're plugging in a number for x, but it's giving you the y value.
Correct. So think of that. She says she's a little confused. This is really like y equals. But we're saying what does y equal when x equals 1? So the function notation tells us what the x value is, and then the number we get is like the y value. Remember? We're going to have like this machine where we have an input and it spits out an output. And usually the function f of x or g of x or h of x is what gives us the output. So I'm saying that this is my input, f is my function that does the work, that's like the machine, and then this whole thing right here is like the output. So the input is usually the x value, the output is usually the y value, but sometimes we call it f of x. And technically, f is the function that operates on it, or g, or h. Does that make sense? Yeah. Okay. So now, if I just look at the graph, this is x equals 2, but what will my y value be? If you were to look at the pattern, what do you think it would be?
6. No, not 6, 5.
5. And how did we get 5? We added 2. Is it in fact 5?
Yes.
1, 2, 3, 4, 5. See how the patterns can help?
Yeah.
Now somebody blurted out 6 because they just looked and didn't count, but then they thought about the pattern and they caught themselves and they're like, oh no. So all this stuff is connected. Now when x equals 3, what do you think this next number will be?
7.
7. And it is. 3, 7. Okay, cool. That's no accident. Now let's go through and do g of x. Now if we do g of x the same way, g of 0 is equal to -2 times 0 minus 2. What's -2 times 0?
0.
Oh, 0.
0, and then when we minus the -2, we get -2, right? Okay, cool. So now, let's do that again for 1. So if I say g of 1, I get -2 times 1 minus 2. What's -2 times 1?
-2.
Okay, plus -2,
You get -4.
-4. What are we doing here?
Adding -2.
Yeah, adding a -2 or subtracting 2. So what do you think this would be? -6. What would this be?
-8.
-8. Let's double check. This is right. Then when x equals 1, we've got 1 comma, that is -4, isn't it?
Yeah.
What's this one?
-6.
-6. So we've got 2 comma -6. And then this last one is in fact 3 comma -8. Right?
Right.
Okay, cool. Now, let's do h of x. H of x is just the sum of these two. We said h of x is equal to f of x plus g of x.
It's just a straight line.
So, well, I think so, but let's just go ahead and do the math, okay? So basically, what I'm going to do is I'm just going to take these numbers and, like, add them. Okay? So what is 1 plus -2?
-1.
Okay. 3 plus -4.
-1.
5 plus -6.
-1.
7 plus -8.
-1.
-1. Okay. Now, there's a pattern, and basically we're going to have -1, -1, -1, -1, -1. In other words, when I graph this, I'm going to have a horizontal line. Are they always going to be horizontal lines? No, it just so happens that this one worked out that way because of the f of x and g of x that Mr. Adams selected. So I've got a graph that looks like this. This is my h of x. Now you guys are you ready to be, have your mind blown?
What?
If I say, watch this, h of x equals f of x plus g of x. The h of x is equal to f of x. What was the function f of x, though?
2 times 2x plus 1.
Plus 1. Okay. Now, what is g of x?
Plus -2x plus -2.
-2. Well, these are, what's going to happen with my 2x and my -2x?
Cancel out.
Those two cancel out. What am I going to have when I have +1 and -2?
-1.
Oh my god.
You think this is a game? Wait, you think I'm just some basic average math teacher?
No.
Yeah.